Hi, 8th grade students. I'm going to work out a couple problems here on this graphing dilations worksheet. So for homework tonight, you're going to do number 1, number 2, number 5, and number 6. I'm going to work out number 3 and number 4 and talk through those two problems together for you. Or you can follow along. It's a dilation of 1/2 for number 3 and a dilation of 1.5. So we got a fraction, we have a decimal. I didn't want those to intimidate you or you to think that you couldn't do those. They are just like any other dilation, and I just want to show that to you. So we've learned from previous videos and discussions that dilation is either going to enlarge the figure if the scale factor is greater than 1, or it's going to reduce the figure if it's less than 1. So 1/2 is less than 1. This is going to be a reduction. And in order to actually perform the dilation, you take each of the coordinates of the figure, and I've already written them here, and you multiply it by the scale factor. So this 1/2 is the scale factor. So we're going to multiply everything by that scale factor. Okay? So I'm going to take each one of these and multiply it by 1/2. So I'm going to do my work for the first ones, and I'm going to show it to you. So m prime would be 3 times 1/2 for the x-coordinate, and then the y-coordinate is going to be -2 times 1/2. So in order to multiply a whole number by a fraction, you can change the whole number to a fraction itself, put it over 1. So it'd be 3 over 1 times 1 over 2, and then you just multiply straight across. 3 times 1 would be 3. 1 times 2 would be 2. We'll simplify that in a minute. So this again is m prime. -2, we do the same thing. Put it over 1 and multiply. -2 times 1 would be -2. 1 times 2 would be 2. Now we just need to simplify to get the ordered pairs for m prime. So 3 over 2, to simplify that, we'd see how many times 2 fits into 3. It fits in there one whole time, which would be 2. We wanted 3, so when we subtract, that means there's 1 left over the same denominator. So 3 over 2 simplifies to 1 and 1/2. -2 over 2, do that division, see how many times 2 fits into 2. We know it's going to be negative, since one of them is negative and one's positive. Fits in there one whole time. So here are the coordinates for m prime. And I can go ahead and graph that. So m prime is at 1.5 for the x-coordinate. So here's 1. 1.5 would be directly in between 1 and 2. So just do your best to approximate where that is. I put that in the wrong spot. I didn't go down 1. So this is the x-coordinate, 1.5, and then I need to go down to -1. So right there is where m is going to be. And then I would do the same thing with L, W, and F. So I'm not going to spend the time going through all of this work for each one, but I'm just going to take 1 times 1/2. So L prime is going to be 1 times 1/2 would be 1/2. -5 times 1/2 would be -5 over 2, and I'm actually okay if you just leave it improper. W prime, 5 times 1/2 would be 5/2. -5 times 1/2 would be -5 over 2. And then F prime, 4 times 1/2 would be 2. 4 times 1/2. -2 times 1/2, I've already done that up here. -2 times 1/2 would be -1. And then we'll plot all of these. So this one was m prime. L prime is going to be at 1/2, which is right here between 0 and 1. And then it's going to be down at -5/2. -5/2 is -2.5. So I'm at 1/2, and I go down 1, 2, and then another 1/2. So L prime is going to be right there. W prime, 5/2, so that's +2.5 for the x-coordinate, which is right here, in between 2 and 3. And then down -2.5, right there. And then F prime is at 2, -1, which is right there. And we just need to draw in our side lengths here. And we'll label everything. Remember that dilations do not result in congruent figures. They result in similar figures. So all we have to do is label these vertices now. So this is M prime, F prime, L prime, and down here is W prime. And there's number 3. Now let's do number 4. So I'm going to get rid of some of this work so I can. So number 4, it's a dilation of 1.5. So this time we're multiplying with a scale factor that's a decimal. So we're going to multiply every coordinate by 1.5. You can multiply it as a decimal, or you can change that decimal to a fraction if you would like and make it 1.5. Either way is fine with me. So we're going to take P. I'll do P prime over here. So P prime, we're going to take -3 and we're going to multiply it by 1.5. Then we're going to take the y coordinate and also multiply it by 1.5. So -3 times 1.5. We know it's going to be negative because one's negative and one's positive. I'll show you how to do this off to the side. 3 times 1.5. I would put the one that has more digits in the top and then put the 3 all the way to the right and then multiply. 3 times 5 is 15, so I drop the 5 down and I carry the 1 in the 15. 3 times 1 is 3, plus the 1 is 4. I count my decimal places. I only have one decimal place, so in my answer I move it over 1. So this is going to be -4.5. 1 times 1.5, well, anything multiplied by 1 is just itself, so this would just be 1.5. So there's the location of P prime. Z prime, we would do -3 times 1.5. We've already done that right here. We know it's -4.5, and the y coordinate's the same because it was multiplied by -3. I prime, take -1, multiply it by 1.5. That means it's going to be -1.5. Anything multiplied by -1 is just its opposite. And then there's -3 again. -3 times 1.5 is -4.5. So there's all of our coordinates for the dilation. And before we plot it, I hope you realize that this is an enlargement because it's bigger than 1. The scale factor is bigger than 1. So this is going to enlarge it. So P prime is at -4.5, 1.5. So 1, 2, 3, 4. -4.5 is in between -4 and -5. And then we need to go up 1.5. So there's P prime. Z prime is at -4.5. -4.5. 1, 2, 3, 4. Way down here. And then I prime is at -1.5. -4.5. Down here. And then connect the sides. There is the figure after the dilation. Let's just label everything here. This one was P prime. Down here was Z prime, and this was I prime. So that video should help you complete number 1 and number 2, as well as number 5 and number 6. For number 5, with that dilation of 1/2, if you need some help, make sure you refer back to number 3, how we multiplied by that 1/2. So I hope that helps. Have a great day, guys.